Welcome to today's lesson about discrete probability distributions. Just to give you a little note, this problem looks more like this normally. I wasn't able to get the table into Excel, so you won't see that there, but it is in the Excel already built in, the file that I've created. That's important because the table helps you note that this is a 5-1 question. Note that it is not a contingency table. It's not a two-way table. It's not measuring two things with rows and columns. It either has rows or it has columns, but not both. The way that I've set it up in Excel, I usually orient it vertically so that it has columns, 2 columns in this case. So we know it's a 5-1 question. The first question, though, is actually not a 5-1 question. It's actually back to Unit 1. What is the shape of this distribution? Okay. You could create a histogram because you've got the frequencies. Sometimes I don't give you the frequencies, they'll give you the relative frequencies. You could still create a histogram and see the shape of this distribution. What you can also do is just create a small sketch, which is what I will do here. And not any glorious, but there would be the 8 for the first column. We know 11 would be higher, then 3 would be down here, and then 2, and then 1. So just a little sketch. It's not labeled, it's not perfect, but it gets the job done, and you should be able to say that this is in fact right skewed. Hopefully you'll get to the point where you can just look at the frequencies and see that it's right skewed, but I think that that might be asking a little bit too much right now, and a little just basic graph will get you there. The probability that a flight has more than 7 crew members. Well, if it's asking for a probability, this means we need to know the total. So I'll get Excel to calculate the total for me. That is the total of the frequencies. I like to skip a row here and have it sum up those frequencies like we did back in Unit 1. So there are 25, and they want to know the probability the flight has more than 7 crew members. And I'll just denote this as part A. So the probability that it has more than 7 crew members, so the probability that we have more than 7 is going to be something divided by 25. And the ones that are more than 7 are 8, 9, and 10, and the frequencies there are 3 plus 2 plus 1. Or 0.24. There is another way to get that. If you are careful with your rounding, the other way will always work. But if you are not careful with your rounding, it doesn't work. And sometimes it would just depend upon the order that the questions were asked that I would take. And I'll show you the other way in a minute. Calculate the mean of the number of crew members. So we have to remember if I can get my pen to write, here we go. The mean for discrete probability distributions that we already identified that this is the sum of x times p of x. So I'm going to create a column that says x times p of x. The problem is I don't have a p of x column, so I first need to create a p of x column. So remember that probabilities can be thought of as relative frequencies, which we know are the frequency divided by the total, which we already calculated to be 25. And just to make sure that we didn't goof up, we can add these up. And just like Unit 1, they should add up to 1. We also know that from the requirements of a discrete probability distribution. They do add up to 1. So I'll create another column that says x times p of x. So in this first row, the x is 6 times the p of x is 0.32. And I cell referenced both of those. And I'll drag that down. And the formula says all I need to do is add these up. Remember the equal sign. And we get 7.08, and in this case it's 7.08 crew members. And before we go on to part D, let me point out a few things. The first one is 7.08 falls between 6 and 10, which was the X-min and the X-max. That's a reasonable number. Especially since it is right skewed, it falls closer to the 6 side, and 7.08 is definitely closer to 6 than it is 10. Also, I wanted to go back to part B. We said the probability that X is greater than 7 was 0.24. Another way you could have also have done this for part B, the probability that X is greater than 7 is equal to 0.12 plus 0.08 plus 0.04. Now in this case, these were all nice, consistent numbers. They all terminated at the second decimal place, so it was very easy to add. If you get numbers that are not nice, the only way this method will work is if you cell reference those numbers that you're adding together. So that's the only thing I don't like about that method, but it's a perfectly reasonable and good method. And then part D, to find the standard deviation. So for the standard deviation, we first are going to find the variance. And there were two formulas in your book. This is the one I'm going to use. You are welcome to use the other one as long as you use it correctly. It's got another summation, and I know this is a little bit different than what your book does. I'm going to put a new column that is named by the summation. And put all of that together. If you want to separate that out into different columns like your book suggests, again, as long as you do it correctly, that is fine. So we have parentheses, and the X on this row is 6 minus mu. Now this time we would be okay if we clicked, if we typed in 7.08, but of course our mean is not always a super nice number like 7.08, so it's good to get in the habit of clicking on it and then anchoring it with dollar signs in front of the number and the letter. Don't anchor it, you will get the wrong answer. Times, and on this row the probability is 0.32. So click on that. Drag that down. And again, add that together. And we get 1.11 crew members. Pardon me, it's not crew members, but so it is 1.11, but it's the variance. So in order to find the standard deviation, we need to take the square root of the variance. And we get 1.06. So I think that should give you a pretty good overview of the type of questions you'll see in 5.1. As always, if you've got questions, please feel free to ask your instructor.